Okay, today's question is uniform product, and it's an easy probability question. I think this question is pretty nice. So let x, y, z be following a uniform distribution from 0 to 1, and they're identically independently distributed. Find p of x greater than y, z. If it was a 2D question, basically what we would do is usually we would map out the square of the area from 0 to 1, and then we would see what area that is. If it's inside here when we have three variables, it would be a cube. So it would be much harder to do it geometrically. So this approach is not very viable. But something we can do is just use the integral calculus approach. We can integrate stuff, and then we would be able to get the volume of the thing. So basically the idea is that we have their joint probability density function is f of x, y, z is equal to 1 because it's just inside this cube. And we're trying to find the probability that x is greater than yz. So basically that's the case when x is greater than yz. So we can just set this up so that we have z, and then this is y from 0 to 1, so it can be anything. And then x has a specific requirement that it starts off at yz and it can end at 1. So then that means that it's greater than. And then we start off with 1, and then we just have this. And we just do it one step at a time. From the first integral, let's say, um, we pick a color, pick white. So basically what we do is we first expand this part, then this part, then the last part, and we would be able to get our answer. So in the first part, when we have 1, we integrate with that respect to yz and 1, x. We get this. So then put this into for y, we get this. And then the last step for a z, we get 3/4. And that's our solution. And a better way or easier way to do this question is actually just to use expectation and um, independence because we didn't use those conditions that well in the first part. So inside here, when we start off px greater than yz, um, we know that x follows this distribution for any constant. So then px greater than k is equal to 1 minus k. So in this sense, px greater than yz is essentially just 1 minus yz because we're just thinking whatever's not that, right? So once we have this equation, what we do is we just, by linearity of expectation, e of 1 is just 1, and e of yz is e of yz. And then we know that we're given that y and z are independent, so we can further break yz into ey times ez. So then we know that the expected value of ey and ez are both 1/2. So then we would just get 1 minus 1/2 squared is equal to 1 minus 1/4. So then we would get the same answer of 3/4. So this is a pretty fun question. I'd say both methods works out quite well and it's definitely doable.